Welcome to this lecture series where we are going to walk through the process of building a complete web project from the ground up. We will cover everything from the initial project concept and how the system works all the way through setting up the website, creating controllers, and building views. This is part one, where we focus on understanding the project overview and getting our initial setup in place. Let's get started. So the project that was started yesterday has a very clear and practical flow. Here is how it works at a high level. First, there is a website, the front end that the public can visit. Shops, meaning store owners or vendors, will visit this website and submit a request by filling out and submitting a form. Once that form is submitted, the system automatically sends an email notification to the admin. The admin is then aware that a new request has come in and can act on it. This is the core loop of the entire application. A shop submits a request and the admin gets notified. Now, before we can send any email to an admin, we first need to actually have an admin. This might sound obvious, but it is an important architectural decision. You build the receiver before you build the sender. So the very first thing the instructor sets up is the admin. The admin will have their own dedicated dashboard. Through this dashboard, the admin can see all the requests that have been submitted through a website. They can view them, manage them, and take action on them. Think of the admin as the control center of the entire application. Let's talk a little more about what the admin dashboard actually does. The dashboard serves as the admin's window into everything happening on the website. When a shop submits a form on the front end, that request shows up in the admin's dashboard. The admin can then see it, review the details, and decide what to do next. On top of that, the admin also receives an email notification, so they are alerted even when they are not actively looking at the dashboard. This combination of a dashboard view and email alerts makes the admin system very practical and responsive. Before diving into the specific features of this project, the instructor makes an important point. Every web project, regardless of what it does, requires the same foundational setup. This was demonstrated previously in a news portal project, and the exact same process applies here. The setup involves creating a controller, setting up views, and organizing your folder structure properly. Once you understand this setup, you can apply it to any project you build. It is a reusable pattern, and that is what makes it so valuable to learn thoroughly. Now, let's get into the actual setup. The first concrete step is to create a page controller. The command used is php artisan make/controller followed by /page controller. This is a Laravel artisan command that automatically generates a controller file for us. Notice that the controller is placed inside a folder called front. This is intentional. By organizing front-end controllers inside a front folder, we keep the codebase clean and separate from any admin-side controllers we'll create later. The page controller will be responsible for handling navigation between pages on the website, like the home page, the about page, and so on. Inside the page controller, the first function we create is called home. This function is straightforward. It simply returns a view. The view being returned is called frontend.home, which means Laravel will look for a file named home inside a folder called frontend within the views directory. This function will be triggered whenever a user visits the home page of the website. The instructor points out that every page on the website, whether it is the home page, the about page, or any other, will have its own corresponding function inside this controller. This is the standard MVC pattern in Laravel. After writing the controller function, the instructor immediately points out a problem. The view file does not exist yet. When the controller says return view of frontend.home, Laravel goes looking for a file called home.blade.php inside a frontend folder within the resources/views directory. If that file's not there, the application will throw an error. So the next step is to manually create that folder and that file. The view file is where the actual HTML for the page lives. For now, it can be as simple as a basic HTML structure with a hello heading, just enough to confirm that the routing is working correctly. Let's take a step back and see how all of these pieces connect together. This is the classic MVC, Model View Controller pattern that Laravel is built on. When a user visits the homepage of the website, a route defined in the web.php file intercepts that request and directs it to the home function inside our page controller. The page controller's home function then runs and returns the view, specifically the frontend/home.blade.php file. That file is then rendered and sent back to the user's browser as a web page. The instructor also notes that during this setup phase, we don't need to constantly check the output in the browser. We just focus on getting the structure right first. So continuing from where we left off, let's map out the complete normal flow of this application. It all starts with the admin. The admin reviews a vendor's contact deal, and once everything checks out, the admin activates that vendor's status. The moment that status is activated, the system automatically sends the vendor their login credentials, their email and password, so they can get started right away. Now, an important detail here, the vendor actually receives two separate emails throughout this process. The first email goes out at registration, and the second email is sent specifically when the admin activates the vendor status. That second email contains the login credentials, the email address, and the password the vendor should use to log in. And of course, the email address itself stays the same. It's the one the vendor registered with, so the vendor knows exactly which email to use when logging in. Once the vendor logs in, they start entering their products into the system. Now, up until recently, the vendor's role was pretty simple, just enter products. But the flow has been extended. As was mentioned, a review system was added recently, and now the vendor's responsibilities are growing further. They're not just entering products anymore. They'll also be involved in managing orders. We'll get into exactly what that looks like in just a moment. On the user side, the flow is straightforward. The user logs in using Google, so there's no separate registration needed for users. They browse the products, add what they want to their cart, place their order, and then complete the payment using Culti, which is the integrated payment gateway. That's the core user journey from start to finish. Now let's talk about the admin panel setup. The admin panel is built using Filament, a popular Laravel admin panel framework. The setup involves running just 2 commands. Once those 2 commands are executed, the admin panel is fully installed and ready to use. The documentation for Filament is available on their official site, and it walks through all the configuration options in detail. After the package is installed, the next step is configuration. The configuration snippet from the Filament documentation is copied and placed into the layout file, specifically right at the starting point of the layout. This ensures Filament loads correctly across the application. And once that's in place, you can start using it in specific parts of the app. For example, after a shop is successfully saved, you can trigger the registration success email right from that point in the code. Here's a really important architectural point. The application has 3 separate authentication tables, one for admins, one for vendors, called tokens, and one for regular users. Each table serves a completely different type of user. Now, when the Filament admin panel login page appears, it's specifically tied to the admins table. So if you try to log in from that Filament login page, it will only authenticate someone who exists in the admins table, not a vendor and not a regular user. So how do you actually create an admin account? There are 2 approaches. The first is to use the registration page within the Filament admin panel itself. You navigate to the admin panel URL, and if a registration page is set up there, you can register directly, and that account lands in the admins table. The second approach is to use an artisan command directly in the terminal, which creates the admin user programmatically. Either way, the result is the same. A new admin user is created and stored in the admins table, ready to log into the admin panel. The reason for having 3 separate tables is security and role separation. Each type of user, admin, vendor, and regular user, has their own dedicated login portal and their own authentication guard in Laravel. This means an admin's credentials cannot be used to log in as a vendor, and a vendor's credentials cannot be used on the main user-facing site. Each portal is completely isolated. This is a clean and secure architecture that ensures the right people have access to the right parts of the system. Let's walk through the complete order lifecycle in this e-commerce system. When a user places an order, the order doesn't immediately jump to a completed state. It goes through a series of status changes, and each status change is controlled by the shop owner. So the flow looks like this. The user places an order, the status starts as pending. The shop owner sees the incoming order and moves it to processing. Once the goods are delivered to the user's location, the shop owner marks it as delivered. And only after that, only when the order is marked delivered, does the system allow the user to write a review for the product. This is a deliberate design decision. You can't review something you haven't received yet. The first status in the lifecycle is pending. The moment a user places an order on the website, the system automatically assigns the pending status to that order. At this point, the shop owner hasn't done anything yet. They haven't acknowledged it, they haven't started preparing it. It's just sitting there, waiting. This is the default starting point for every single order in the system. Once the shop owner logs into their dashboard and sees the new order, they move it from pending to processing. This signals that the order has been acknowledged and is actively being worked on. Maybe the items are being packed or the delivery is being arranged. This status change is done manually by the shop owner through the admin panel. It's a deliberate action, not automatic. The third status is delivered. When the product actually reaches the user, the shop owner goes into the dashboard and marks the order as delivered. This is a critical step because it's this exact status change that unlocks the review feature for the user. Before this point, the user simply can't submit a review. The system enforces this rule. It makes perfect sense from a real-world perspective. You should only be able to review a product you've actually received. To make this really clear, here's the before and after. Before the shop owner sets the status to delivered, the review option is completely locked for the user. They simply don't have access to it. But the moment the shop owner marks that order as delivered, the review feature becomes available. The user can now go in, rate the product, and leave their feedback. This is the full intended flow of the system. So to bring it all together, this 4-step flow is the backbone of the order management system. The user places the order, it goes pending, the shop owner processes it, the shop owner marks it delivered, and then the user gets to review it. The instructor also points out that to support all of this, the team has already built out the database models, written the migrations, filled in the data, set up the relationships between models, and run the migrations. All of that groundwork is already in place. This flow represents the complete lifecycle of the website's core functionality. Now let's shift to email notifications. Here's the situation. When a new shop owner fills out the registration form, the data goes through the controller and gets saved to the database. At that point, the system is supposed to send an email to the admin to let them know a new shop is registered and is waiting for approval. But there was a problem. There was no admin account in the system yet. You can't send an email to an admin that doesn't exist. So the first thing the instructor did was create an admin account, and that required setting up some infrastructure first. To create an admin, the instructor first had to set up what's called a guard. In Laravel, a guard defines how users, or in this case admins, are authenticated. So a new guard named admin was created. This guard was then linked directly to the admin's database table, meaning when someone tries to authenticate as an admin, the system checks against that specific table. Then, in the admin panel provider, the auth guard was set to use this new admin guard. This wires everything together, so the admin panel knows exactly which table and which authentication logic to use. Here's how these 3 pieces connect. The admin panel provider is configured to use the admin guard. That guard is linked to the admin's table in the database. So when someone logs into the admin panel, the system goes through this chain. It checks the admin guard, which checks the admin's table. This is important because it keeps admin authentication completely separate from regular user authentication. Admins and users are stored in different tables and authenticated through different guards. Now that the admin account exists, here's the full email notification flow that's being planned. When a shop owner registers, the data is saved to the database, and an email is automatically sent to the admin. The admin then logs into the dashboard, reviews the new shop registration, and activates the account. Once the admin activates it, the system sends another email, this time to the shop owner, containing their login credentials. So there are 2 emails in this flow, one to the admin when a shop registers and one to the shop owner when their account gets activated. The instructor notes this will be fully implemented in the next session. Now let's talk about a form validation issue that was identified. Here's the scenario. A user fills out the registration form. They enter their shop name, their email, their contact number. They hit submit. But there's a validation error. Maybe the email is already taken. The form reloads and shows the error message. That part is fine. But the problem is that all the other fields the user had filled in, the name, the contact number, they're gone. The user has to type everything in again from scratch. That's a frustrating user experience, and it needs to be fixed. The fix for this is Laravel's built-in old helper function. For every input field in the form, you set the value attribute to old with the field name passed in. So for the name field, you write value equals old name. For email, old email. For contact, old contact. What this does is when Laravel redirects the user back to the form after a validation failure, it flashes the previously submitted values into the session. The old function retrieves those flashed values and puts them back into the form fields. One important thing to note, for text areas, there's no value attribute. Instead, you put the old call between the opening and closing text area tags using the double curly brace syntax or the unescaped version with exclamation marks. It's worth understanding exactly when old works and when it doesn't. On a fresh page load, when someone visits the form for the first time, old returns nothing. All fields are empty, as expected. But when Laravel redirects the user back to the form because of a validation error, it stores the submitted values in the session temporarily. In that case, old picks up those stored values and populates the fields. The instructor also makes an important clarification. If the user manually refreshes the page, those old values are gone. They only survive during the immediate redirect from a validation failure. Another small but important fix was adding a unique validation rule for the contact number field. The instructor noticed that while other fields had the unique constraint, the contact number was missing it. The fix is straightforward. In the validation rules, you add unique::ducans, contact number. This tells Laravel to check the ducans table, look at the contact number column, and make sure no existing record already has that same number. Every shop should have a unique contact number, so this rule makes sense and should have been there from the start. Looking ahead to the next session, there are several important pieces still to be completed. The submitted shop registration data needs to be pulled into the admin dashboard so the admin can actually see it. Then the email notification system needs to be wired up, sending an alert to the admin when a new shop registers. After that, the admin activates the shop, which triggers a credentials email to the shop owner. And finally, the shop owner's own login panel needs to be built and tested. The instructor wraps up by noting that today's session covered two relatively small but important topics: using the old helper to preserve form input after validation errors, and setting up the auth guard for the admin. Everything else was review and continuation of existing work. Picking up where we left off, the instructor now moves into building out the front end of the application. The first step is creating 3 core Blade components using PHP Artisan: a front-end layout, a front-end header, and a front-end footer. These are generated using Pascal case naming conventions when passed to the Artisan command. No, the file system stores them in kebab case automatically. What's important to understand here is that when you create a component this way, Laravel also generates a corresponding Vue file inside the Views directory. The instructor notes that the Vue files inside the Views folder don't need to be run separately. They're called through the layout system. The layout file is where all the boilerplate HTML structure lives, and the header and footer are separated out as their own concerns. Inside the layout file, the instructor builds out the standard HTML boilerplate. There are a few key things being pulled in here. First, Tailwind CSS, the utility for CSS framework that handles most of the styling. Second, Font Awesome for icons. Now, the instructor originally considered downloading Font Awesome locally, but decided to keep things simple by pulling it in via a CDN, specifically from cdnjs.com. You just search for Font Awesome there, click the link, copy it, and paste it into your layout. Third, there's a custom style sheet at public/frontend/style.css. This file is where custom CSS color variables and other project-specific styles will live. The layout also includes the header and footer components using Blade's @include directive, and uses @yield content as the placeholder where child views, like the homepage, will inject their content. The instructor creates a dedicated CSS file at public/frontend/style.css. The idea here is to define CSS custom properties, also called root variables, for colors and container styles. However, the instructor makes a deliberate decision. Rather than manually defining all the colors right now, they'll let the AI generate the design and then extract the color variables from that output. This is a smart workflow. You let the AI produce the fade design, and then you organize and separate the styles into the right files. The instructor also defines a container class in this style sheet so that a consistent layout pattern is used across all pages, rather than relying on different container approaches in different places. With the layout in place, the instructor wires up the route. In the web.php routes file, a get route is defined for the root URL, the /. This route calls the home method on the page controller class, and the route is given the name home for easy reference elsewhere in the application. The page controller's home method simply returns the frontend.home view. That view then extends the front-end layout, which wraps it with the header, footer, and all the boilerplate HTML. So the full chain is: browser hits the root URL, Laravel calls the controller method, the controller returns the view, and the layout assembles the final page. The instructor also comments out any previously existing routes to keep things clean. Before diving into the AI-assisted design process, the instructor takes a moment to explain which AI tools to use and when, and this is genuinely useful advice. DeepSeek is ranked as the top priority for front-end work. It produces excellent HTML, CSS, and JavaScript designs, and importantly, its token limit doesn't run out easily. Claude is described as the all-rounder, great for everything, but its tokens get consumed very quickly. The instructor jokes that Claude is the backup. When everything else fails and you desperately need an answer, Claude is there. Grok is good for logical and back-end problem solving, but it doesn't give you full code rewrites. It tells you what to change and lets you make the edit yourself, which actually makes it useful for debugging if you already understand the code base. ChatGPT is for simple conversational questions, and Gemini is best suited for image-related tasks. The instructor chooses DeepSeek specifically for this front-end design task and explains why in detail. DeepSeek produces genuinely impressive front-end designs. The HTML, CSS, and JavaScript output is clean and well-structured. And unlike some other tools, you can use it extensively without hitting a token wall. You access it at chat.deepseek.com. Once you're there, you'll notice 2 modes: instant, which is faster, and expert, which takes a bit longer but produces more thorough results. The instructor uses expert mode. Now, the key insight here is about how to prompt the AI. Don't just say, "Make me an e-commerce front end." Instead, tell it your coding patterns. For example, put color variables in CSS root variables, use a container class in the style tag, use Tailwind for utilities. The more context you give about your project structure, the less debugging you'll need to do afterward. Here's what an effective prompt to DeepSeek looks like for this project. The instructor specifies that this is an e-commerce front-end design using both custom CSS and Tailwind. Crucially, they tell the AI to define colors as CSS root variables, because if you don't say this, the AI might just hard code Tailwind color classes everywhere, which is harder to customize later. They also specify the container pattern, section wrapping a div with a container class so that every section of the page follows the same structural pattern. For the registration form, the instructor lists exactly what fields are needed: name, email, contact number, and an optional message or status field. The instructor deliberately avoids asking for too many things at once, because the more specific and structured your prompt, the more usable the output will be without heavy modification. Once DeepSeek generates the code, the instructor walks through a careful integration process. The first thing to do is remove the Tailwind CDN link from the AI's output, because the project already has Tailwind set up, and having two copies would cause conflicts. Then the HTML structure goes into the front-end home blade view. The style block, containing all those CSS root variables and custom classes, gets moved into the dedicated style.css file in the public front-end folder. After that, you run npm run dev to compile assets and check the result in the browser. The instructor is upfront about something important here. The AI's output might not look exactly the same on your machine as it does in the demo. This is because the AI might generate Tailwind classes that correspond to a slightly different version than what's installed in your project. That's normal. You'll need to do some minor debugging to align things. One issue that comes up during this process is a Tailwind version mismatch. The AI might generate code using Tailwind class names or configurations that don't match the version installed in your project. The instructor handles this by checking the package.json file to find the exact Tailwind version and then telling DeepSeek that version in a follow-up prompt. DeepSeek then regenerates the relevant parts with version-appropriate classes. There's also an important production note here. Using a CDN version of Tailwind is fine for development and prototyping, but for a production application, you should always use the npm installed version that gets compiled and optimized. The CDN version loads the entire Tailwind library, which is much larger than a properly purged production build. While the AI is still generating the front-end design, the instructor switches over to building the back-end, specifically the shop registration function. This is a great parallel workflow. Let the AI work on the front end while you manually write the back-end logic. The function is called shop registration, and it accepts a request object as its parameter. The request object is Laravel's way of capturing everything that was submitted through the form, all the post data. Inside the function, the first thing you do is validate the incoming data. The instructor uses Laravel's built-in validate method on the request object. Each field gets its own validation rules. Name and email are required, contact number is required, and the message or status field is nullable, meaning it's optional. This mirrors exactly the fields that were specified in the AI prompt for the front-end form. The instructor pauses here to make an important distinction that's easy to overlook. Earlier in the course, validation was shown in the context of an API, where errors are returned as JSON responses with HTTP status codes. But now we're in a blade-based front-end context, and validation works differently here. When you call the validate method in a controller that's serving a blade view, Laravel automatically redirects the user back to the form if validation fails, and it flashes the error messages to the session. Those errors are then available in the bleed template through the $errors variable. So the same validate method behaves differently depending on whether the request expects a JSON response or an HTML response. This is one of Laravel's elegant automatic behaviors. It detects the request type and handles the response appropriately. Understanding this distinction is crucial as you build forms in a full-stack Laravel application. To bring this section together, here's the overall workflow the instructor is demonstrating. There are essentially two parallel tracks happening at once. The AI, in this case DeepSeek, handles the visual design work, generating the HTML structure, CSS variables, Tailwind utility classes, and form markup. Meanwhile, the developer handles the structural and logical work, creating blade components, setting up routes, writing controller methods, and building validation logic. These two tracks converge when you take the AI's output, clean it up, integrate it into your blade views, and connect it to the backend controller. The key philosophy here is that AI handles the tedious design generation, but you, the developer, remain in control of the architecture, the patterns, and the logic. You're not just accepting whatever the AI gives you, you're guiding it with specific instructions and then organizing its output into a well-structured codebase. Let's talk about form validation in Laravel. The instructor points out that this is actually quite straightforward. You only need to write one thing, $request validate, and pass in your rules array. There's nothing extra to configure. Inside that array, the structure is the same as you've seen before. Field name on the left, rules on the right. For example, name gets required. You can add max 255 to limit the length, and so on. The content inside the validate call is the same pattern every time. Now, let's go through the validation rules field by field. The name field is required with the max length. The email field is required, and it also needs to be unique, meaning no two shops can register with the same email. The syntax for unique is unique, colon, then the table name in plural form, so docans, then a comma, then the column name, which is email. The contact number is required and must be numeric. The message field is optional, but can have a max of 255 characters, since it was stored as a string. A student asked why docans is used, and the answer is simple. Laravel table names are always plural by convention. Once validation passes, the next step is saving the data to the database. The instructor creates a new Dukan model instance, assigns each field from the request, name, email, contact number, message, and then calls save. After saving, there's an important rule to remember. When a function is triggered by a post request, you should never return a view directly. A view is essentially a page, and returning a page from a post method is bad practice. Instead, you must redirect. In this case, the instructor redirects to the home route using redirect arrow route home. Let's make this crystal clear. When a form is submitted, it uses the post method. The controller receives that post request, processes the data, and saves it. Now, if you try to return a view, which is just a page, directly from a post method, that's considered bad practice. It can lead to issues like form resubmission when the user refreshes the page. The correct approach is to always redirect after a post. The instructor redirects to the home route, which then loads the appropriate page cleanly. This is a fundamental web development principle, not just a Laravel rule. After saving data, you typically want to show the user a toast notification, a small pop-up that says something like, submitted successfully. The instructor mentions that Laravel's built-in toast or flash message system might not work smoothly in the current version being used. The alternative recommended here is Sweet Alert 2, sometimes written as Sweet Alert 2. It's a popular JavaScript library for beautiful alert dialogues and toast messages. The instructor notes they'll integrate it later, possibly the next day, because installation can sometimes take a moment, and they don't want to break the flow of the current session. Now let's look at the route that handles the form submission. In the web.php routes file, the instructor defines a post route at the URL /dukan-registration. It points to the store method inside the Dukan controller. The route is given the name Dukan_registration. One important convention the instructor highlights, in URLs, use hyphens rather than underscores. So the URL is Dukan-registration with a hyphen, but the route name uses an underscore. This is a common web convention. Hyphens in URLs are more SEO-friendly and readable. To connect the HTML form to the backend route, the form tag needs two key attributes. First, the action attribute. This is set using the route helper function with the route name Dukan registration. Second, the method must be post. And critically, inside any post form in Laravel, you must include the @CSRF directive. This generates a hidden CSRF token that protects against cross-site request forgery attacks. Without it, Laravel will reject the form submission with a 419 error. Now, when validation fails, Laravel automatically sends the errors back to the view, but you need to display them. The instructor adds an error paragraph below each input field. The errors variable is automatically available in every Laravel view. You don't need to pass it manually. For each field, you check if there's an error using errors has field name, and if so, display the message variable, which contains the error text. The instructor also styles these messages with the Tailwind CSS class text red 500 so they appear in red, making them clearly visible to the user. A quick tip, you can use Ctrl-D to select multiple occurrences and add the class to all error paragraphs at once. The instructor does a live test to show how validation works. First, with the HTML required attribute present on the inputs, submitting an empty form is blocked by the browser itself. Laravel never even sees the request. That's client-side validation. Then, the instructor removes the HTML required attributes and submits the empty form again. This time, the form reaches Laravel. Laravel's validate method runs, it fails, and the user is redirected back to the form with error messages displayed in red under each field. This is server-side validation. The key lesson here, always implement server-side validation, because client-side validation can easily be bypassed by anyone who knows how to use browser developer tools. During testing, an error appeared. The database table docans doesn't exist. The instructor explains there are two possible reasons for this. Either the migration was never run, or there's a spelling mistake somewhere. The instructor checks the database and confirms the table simply doesn't exist. The migration was never executed. The fix is straightforward. Run php artisan migrate. After running the migration, the table is created, and when the form is submitted again, the data saves successfully. This is a common mistake. Always remember to run your migrations after creating them, especially when switching between projects or databases. Now, the instructor raises an important question. When someone registers through the admin panel, which of the three tables gets the data? Users, admins, or ducons? The answer is the users table, because that's Laravel's default behavior. Laravel ships with a default authentication setup that points to the users table. The instructor recalls that even in previous projects, like the NJ portal, the same thing happened. The admin model was using the users table under the hood. So right now, even the admin panel registration is saving data to the users table, not the admins table. This needs to be fixed. To understand why data goes to the users table, you need to understand Laravel guards. The instructor opens config/auth.php. At the top, there's a default section that sets the default guard to web. This means if you never specify a guard anywhere, Laravel automatically uses the web guard. The web guard uses the session driver, meaning authenticated user data is stored in the session table. It also uses the user's provider. The user's provider uses Eloquent as its driver and points to the user model. The user model maps to the user's table. So the entire chain leads to the user's table. That's why all default authentication ends up there. To fix this, the instructor creates a custom guard for admins. In config/auth.php, under the guards array, a new entry called admin is added. It uses the same session driver as the web guard, but its provider is set to admins, plural. Then, under the providers array, a new admins provider is added. This provider uses the Eloquent driver and points to the admin model. Now there's a complete chain. The admin guard uses the admin's provider, which uses the admin model, which maps to the admin's table. The instructor emphasizes that the names on both sides, guard name and provider name, need to match up correctly, but they don't need to be identical to the table name. Now that the admin guard exists, it needs to be applied to the admin panel. The instructor goes into the admin panel provider file and adds the authGuard method, passing in the string admin. This single line tells the admin panel, instead of using the default web guard, which looks at the users table, use the admin guard, which looks at the admins table. After making this change and refreshing, the instructor tests registration again. This time, checking the database confirms that the new entry is saved in the admins table, not the users table. The fix works perfectly. After applying the admin guard, the instructor does a live verification. A new registration is submitted through the admin panel. Checking the database, the new entry appears in the admins table, not the users table. This confirms that the guard configuration is working correctly. Without this change, every admin registration would have silently gone into the users table, which would cause serious authentication issues down the line. Admins wouldn't be able to log in because the system would be looking in the wrong table. This is a subtle but critical configuration step. The instructor also works on organizing the front-end code by extracting reusable layout components. Instead of repeating the header and footer HTML on every page, you cut them out and place them in separate component files. Then on each page, you simply call the component using the xheader and xfooter tags. The main content area uses a slot, which acts as a placeholder for whatever unique content each page needs. This is a standard component-based approach that makes the codebase much cleaner and easier to maintain. If you need to update the header, you only change it in one place. During the session, several AI tools came up in discussion. The instructor primarily uses Windsurf for AI-assisted coding. Students asked about various alternatives, ChatGPT for code generation, DeepSeek, which the instructor notes used to give very clean code, GitHub Copilot, which integrates directly into VS Code with a chat sidebar, Ant Gravity, which is essentially a VS Code alternative with Gemini AI built in, and Perplexity AI for research. The instructor's overall take: once you've reached a solid understanding of the fundamentals, you can start using tools like vibe coding, where the AI writes most of the code and you focus on debugging and fixing the logic. But you need the foundation first. Let's wrap up by reviewing the complete flow of what was built in this session. The user fills out the shop registration form on the front end. When they click submit, the form sends a post request to the /docon registration route. Laravel's controller receives this, runs the validate method, and checks all the rules. Name is required, email must be unique in the docons table, contact number must be numeric. If any rule fails, the user is sent back to the form with red error messages. If everything passes, the data is saved to the docons table, and the user is redirected to the homepage. Separately, the admin panel now uses a custom admin guard that points to the admin's table, so admin registrations and logins are completely isolated from regular users. Let's close with the key takeaways from everything covered in this session. First, Laravel form validation is simple. Just use request validate with your rules array. Second, the unique rule needs the table name in plural form. Third, after any post request, always redirect, never return a view. Fourth, use the errors variable in your blade views to show validation error messages. 5th, Laravel guards control which database table is used for authentication. 6th, you can create custom guards in config/auth.php and link them to custom providers and models. 7th, apply the guard to your admin panel using the auth guard method. 8th, never forget to run your migrations. 9th, extract headers and footers into reusable components. And 10th, always validate on the server side, because client-side validation is just a convenience, not a security measure. These are the building blocks of a solid, secure Laravel application.